photograph shows a spark coil, a device used in early experiments on electricity. The diagram shows the parts of the spark coil similar to Ruhmkorff coil. A coil of wire P is wound around an iron core. A second coil S is wound around P. The ends of S are connected to two thin metal rods with a gap G between them, known as the spark gap. With the switch closed, there is a current in P. When the switch is opened, a larger potential difference is produced across S, and the spark is observed across G. Explain how potential difference is produced across the ends of S. As the DC passes through the primary coil P, this current generates a larger magnetic flux density around the iron core. When the switch is opened, we will suddenly stop the current, and then the magnetic field density to collapse. There is a significant change in magnetic flux to time inside the primary coil. Moreover, a change in magnetic flux linkage to time is associated with a larger number of turns in the secondary coil S. And according to Faraday's law formula, which is epsilon equals minus n delta phi divided by delta t. As a result, there is a larger induced electromotive force across the secondary coil S. I have some advice for all year 13 students. Keep in your mind there is a DC current or the direct current, not an alternating current. There is no alternating magnetic field. Secondly, the reason for having an induced EMF electromotive force across the secondary coil S is due to change in magnetic flux linkage N phi, and the number of turns in the secondary coil, and phi is the flux. So I would say it's magnetic flux linkage and is present in the secondary coil. The most important or the crucial final point is to show the significant change in magnetic flux, because we have a DC or the direct current, and there is not an alternating magnetic field or flux. And by the end, if you'd love the video, leave a comment and do not forget to share and like and subscribe to our channel, and see you next video.